Urtasun. So now we have all the amazing speakers here, and they can start their questions. I start with one question, but if you have one, you can come up to the microphone. And I'll start with one question about benchmarks and metrics for Joelle, because she's leaving a bit earlier. So Joelle, what do you think is the role of benchmarks in all of this? Because we could also over-optimize on a particular benchmark and then actually not solve the real problem, but benchmarks seem to be really helpful to compare results. I guess it's benchmarks and metrics, I guess.
And I think metrics are part of a benchmark. So I'll start with benchmark. I think there's two uses for them. One use is more as a controlled experiment. So if everyone is using the same benchmark, you're controlling some factors of variation, which makes it easy to, do A/B comparisons. The second thing that I think is really useful is sort of giving a view across a community of like, where's the next big step in terms of solving a problem? Because if you try to solve something way too hard, you don't really see the velocity of your progress. If you start work on something too easy, probably not worth the effort. And so agreeing on a benchmark is an opportunity for a community to force that conversation of what is the right next step to do that. And we've seen this over, I think you mentioned some of the benchmarks, for example, on from DARPA in terms of autonomous driving, things like that. I think, picking one that's like hard enough, but not too hard, gives you that sweet spot of really forcing the research community to make that gap in progress. And we've seen that in many other fields also in machine learning.
Yeah, great. And then we've seen a couple of different kind of simulation environments. And I'm wondering, maybe a question for the two of you. There are so many different simulation environments out there right now. Should we converge to one? Is there a value of having many? How is that kind of affecting the community?
That's a hard answer, right? It would be nice if we could converge to one, but I don't think we can easily determine which one, right? So, but on benchmarks, I mean, for reinforcement learning, there has been traditionally the Mojoko benchmarks, right? Even though they are not really very good for the actual robotics, they are very synthetic toy problems, but it's still a benchmark that is being used almost everywhere in reinforcement learning, right? Like the Mojoko and humanoid. So, and I've seen some efforts doing such a similar benchmarks for robotics. Like Vikash Kumar, he had a benchmark with a little dynamixel-based hand, and there's also some kind of little robot that can walk around. So there is it's called Robo, I think, Robo benchmark. But I don't think it got much traction, so because no one uses that robot. So
I mean, there's lots of things, that eventually we can discuss, which makes a benchmark succeed or not, right? I think in many ways, in terms of the two properties I proposed for Mojoko, at least, it meets the first criteria of reducing the factors of variation to allow side-by-side comparison. I'm not sure it anymore meets the second criteria, which is kind of setting an interesting step for the research community in terms of what problem to solve. It did at some time.
It depends also what robot that you have in mind, right? Like each domain of robots has its own benchmarks. Like quadruped robots want to work on stairs at least.
Yeah.
And
not even each robot, each task, like this robot doing this task has its own benchmark. So it's like very diverse, like what benchmark for what task, like this doesn't apply to the other application, right? And back to your question about unifying, I don't think maybe you cannot unify to one tool, but I think definitely it's time to reduce amount of all the tools, because in many labs, you have one tool to do this part, then there's another simulator to do that part. The robotics is hard itself. I remember my graduate days, like working with 3 different tools to do like different parts is just really, make things more complicated. And robotics is really fragmented. Like this robotic factory has its own simulator and its own controller, right? So it's maybe not converging to one, but really have to become more unified, right? Okay, just these set of tools, let's all work together like on that set, right? So make the life easier. Right?
Yeah, I guess Ross has also played a bit of a unifying
Exactly.
role.
So not even, maybe not to one tool, but like make it easier. I think that's why we like Omniverse, because maybe helps that. For example, Mojoko would be a great physics simulator. You can make that as a backend for Omniverse, right? So it's not that you have to stick to it. You can have many different backends for rendering, for physics, but makes it easier to unify all these efforts together. So I think that will be very helpful, because yeah, there's a lot of tools. If anybody is like a small simulator, somebody designed it somewhere, I've been working with it, don't touch it, it's worked, I'm not going to change anything, right? So maybe more unified will be helping.
Yeah,
us.
maybe instead of unifying on the simulator software, you can also unify on the data sets like we did with ImageNet. So we could actually define the observations and make that into a data set, and then also the rewards that you get. And then you turn the simulation into, like you generate the output of the simulation.
Right, or unify on the interfaces.
Yeah,
Interfaces,
yeah.
exactly.
I think also something worth considering is that sometimes we think of as benchmarks as something fixed, but as we deploy into the real world, we see things that we may not have seen in simulation. So we have to also think about iterating over the benchmarks as we learn more about the problems that
Yes,
we're dealing with.
Another idea is that using actual hardware as the benchmark, because otherwise the sim to real gap will not be solved if you just stick to the simulator. Like I think there has been some kind of grasping benchmarks where the manipulation of objects. So maybe you can set, but then the hardware needs to be affordable so that everyone can, or you make a cloud-based test of your benchmark. So you can just log in and submit your
So an interesting one I'll mention is on the NLP side, there's a new one called DynaBench. And the property of DynaBench is to allow the community to contribute, in particular adversarial examples and so on. So to think of a benchmark as not being static, but as a benchmark being a way to facilitate, presentation of a common set of tasks.
That's interesting. Yeah,
Yeah.
I hadn't known.
Yeah, and there's also a nice project that I want to call out, is the F-110s, the self-driving cars. There was a contest this week with the F-110, and they are very affordable actually. And you could actually use them to benchmark perception and self-driving autonomy, basically autonomous driving. And but anyway, you're stuck to platforms all the time again. So.
You get lots of good suggestions. It's great that you call these examples out. Let's go to one question here in the audience.
My question goes in the similar direction right now for many, especially mechanical simulations. There are specialized tools, for example, car sim, which is highly specialized for cars. And there are probably tools for, I don't know, surgeons or fluid dynamics. Do you see in the foreseeable future any chance to have a simulator that unifies this all or is capable of simulating all of this?
I would say, I think I talked to Mish about Omniverse, but that is the goal of Omniverse, right? The reason that they're for example, many industries are a combination of other industries. Like if you have, let's say, a car industry, there's architecture, there's part of it is pure mechanic, then there's part of it is algorithm. You can, the fun part is you can build your own application with using a backend. So I'm guessing we do need that because robotics is never alone, right? Robotics is always part of a bigger industry. Like it could be like mining or nucleus or logistics, but it is connected to another industry. So bringing those simulators, connecting to those tool sets is going to be very essential, right? This is the goal, right? We're headed that way, at least in NVIDIA. And we'll basically trusting the community to get on board and with this, right? We already say build your own connector, build your own application on top of it, is just to try to unify all these efforts.
Yeah, I want also bring up that if you want to unify those things, you also need the same data format.
Right.
And I think the robotics industry or the robotics community did a good job in you having URDF and SDF with Gazebo and ROS. So there's already standardization on how to define a robot because there's a lot of different ways to specify a robot. And with USD, you can actually do that same thing with even more rich format, like visual, quality. Yeah.
I would add, I think at the end of the day, it's a question of what's the level of abstraction that we can afford And I mean, by what we can afford, I mean, in terms of either, I think you could decompose it nicely in terms of our analytical models versus our data-driven models. And so we need to have a deep understanding either of an analytical model or have the data to feed a data-driven model. And so right now we're into more what I'll call, local low-level models, because that is what we can do in terms of those tools. And as we get better analytical models and more data, we'll be able to raise that level of abstraction and create these more unified world models.
Yeah, I think the most sophisticated ones is probably finite element methods.
Yeah.
And yeah, I just wanted to know if it's in the foreseeable future possible to run this in real time.
I thought, doesn't Isaac Jim or Isaac Sim have finite element method in there already?
I think the physics does have finite element methods, yes.
Okay.
And just to ask, so is the strategy for NVIDIA to keep this open source? I think that is something that is important for the community.
So there will be two different parts of it. The gym, for example, the Isaac gym that is becoming part of Isaac Sim, part of it will be open source, part of it not. It is going to be more open as it goes. The reason that the whole thing doesn't go open source at the beginning, but there's some IPs on the rendering side, so not the whole engine is going to, the plan is not that the whole thing becomes, but there will be part of it. For example, the Isaac gym, all of the examples, everything is going to be in a Git repo. It is going to be open source. People can try it out. Part of it is part of the tool set. That part is not going to be open source. So it's going to be a mix there. But Erwin does a lot of work that is, most of it would be open source.
Yeah, but if you set a standard with Omniverse with different functionality, you probably will, if you don't open source it yourself, someone else will start providing the functionality, like Mojoko or another physics open source solution. So you might be a little bit less efficient, but it might still work. Right?
That's true. And because we know, robotics are used to open source. There's a reason that ROS is successful, because everybody can contribute to it, right? Being closed in this, I think in this world, being closed is not going to do good to anyone, right? So the plan is to be as open as possible, maybe small features that are very special or IP protected, those not, but the rest is going to be the plan to be as open as possible.
Because we still have to make so much more progress to have the next robotics applications that we all have to work together.
That's true. That's true. Yeah.
Okay, let's take one more question from here, and then we can also see if we have an online question.
Hello, I'm Joelle Pineau from Royal, and I have a question concerning the energy efficiency. So now we are, making increasingly complex simulations, and we are throwing watts and watts into it. We have hundreds, this is also good for application. We need thousands of kilowatt hours just to do replication. So how do we go forward? At some point we have to stop increasing the energy consumption. So how do we go forward?
I'm totally with you, but think of it this way. If you don't do it in simulation, you have to have those batteries on a robot, right? So you're using energy one way or the other, right? Here is a heat sink of a GPU. The other one is a battery or so another GPU on a robot. But I totally get that point. We have to be mindful of the total energy that we're using. And I think the way to go is just to be as optimized as possible, right? That's the way. But there's no
I might have one idea about energy efficiency, unless, but basically, if you look at people, for example, we are very energy efficient, because if we do perception, we don't perceive all the pixels of your eye all the time, right? You're very optimized for seeing differences in the previous, what you're expecting. As Carl Friston, this free energy principle, where you already try to anticipate what's going to happen. And if it doesn't happen, then you get surprised, which is kind of the difference between your expectation and what actually is being perceived, which is like a differentiable model, right? So I think differentiable simulators have that also capability in the future, that you actually look at the gradient or the difference, and then you are much more energy efficient. So instead of using reinforcement learning, you can use gradient-based optimization, for example. That's one little step in the puzzle, of course, but.
What about emulation? So you stop simulating and you get only the gist of what you need from the environment.
How do you get the gist of the environment?
That's one of the things, is through learning itself, and but I don't know. This is idea, just idea. I don't have a solution.
Yeah.
You tell me. All right. Thank you anyway.
Yeah.
Great. Do we have an online question? Yeah, cool. Do we have?
We have two relatively simple questions. One was about Isaac for platforms, and another one was
Can you come here?
about the simulation technologies. Which
I think you need to speak here, otherwise the room will not hear the online.
So from the internet, we got a couple of questions. One was about portability of Isaac Gene for platforms, for Windows specifically then. And the other one was about which simulation technology specifically is that okay.
Okay, sure. I go. Yeah, actually, the release that is coming in June will be available for Windows for the first time. Previously, was only Ubuntu 18.04 and 20.04, but the release coming in June will be on Windows with some limitation. For example, you don't have ROS on Windows, right? So some of the capabilities will not be there, but we will have a Windows build
Okay, so to reiterate, Isaac will be available
on Windows.
on Windows.
Yes.
And
Yes.
now the specific question was, what simulation technologies of are you using? Are you having a completely proprietary simulation environment, or do you rely on community tools?
So this is part of our business model, but we have some upcoming publications where we will be more open about the technologies that we currently use.
Okay, okay, great.
So any macOS development in case?
Any,
Also Mac OS development.
no, Mac is coming later, right? Because it's not that favorable in robotics community, right? So we go based on how like people first on Linux. Windows is mostly two reasons for Windows. Windows because big industries like automation industries, all of those are all Windows, like big arms or big like industry. That's why we're moving towards Windows. Mac is coming a bit later, hopefully.
Some people never.
Yeah.
I do one question and then we go back to you. Joelle was saying we need the right benchmarks, not too far away, but like doable, but challenging. Do you have ideas for the next benchmarks?
We do some, again, like to me, benchmarks are very, very application specific, right? So for example, I can give you one example that we're trying to work on the benchmarking. Is that in the next release that is in coming June, we're giving like a workflow how to train for pose estimation for pick and place, right? And for that, we're doing all this, we are using only synthetic data to detect the pose of the objects, right? Right now, there are different methods of how to do this, but in order back to this, the efficiency, we're trying to benchmark it in terms of to me, the way I see synthetic data is, okay, now I'm in charge of my world, right? If you just use the real data, you get whatever is out there. But now if I'm building it, I know what to, okay, should I do randomize only the lighting? Is that more important? Is it having the realistic model important, or is that not important? So benchmarking that and figuring out what is the best way to like quickly get the best model for, let's say, pick and place among different objects, like start with the cube, let's go for 5. You have to even limit the number of the object. Let's say you have 5 objects, a banana, a ketchup, or like a ball, and then you want to detect the pose of all of this with synthetic data only. And you just have a lot of knobs to turn from the randomization, from like the method that you use, what the background, and do the benchmarking, and then you did come with the recipe. I was like, oh, this is the best way with, like, let's say synthetic data, I can do object detection, right? So this is the way we're doing benchmarking, but it's going to be very, very use case based, right? Then you go to another one, which is, okay, now I want to do like something on a warehouse. That would be its own scenario. I think we're taking it a use-based.
On a personal note, this was really interesting because I do have a student working on this. And
Yeah.
we also saw that through data engineering, we can push success rates of like 20%.
Yeah, I think this is like the whole idea here is I have a lot of knobs, right? So let me create whatever is the best and play with it and just come up with, yeah, so great, we can work with your student. Why not?
But I think for a benchmark to be successful, you need to have agreement on different parties to use the same benchmark. Otherwise, everyone has their own benchmark, and it's not a benchmark anymore if everyone has their own.
That's true. Too.
Right?
Yeah, yeah. Are we going too early in one specific application? Maybe we need a bit more generic benchmark that is interesting for a wider group of people. Do you have an idea?
I mean, I think for locomotion, we have done a lot of research to solve the low-level locomotion. So I think we can move away from that. We have seen the animal jumping around and can do almost everything. So it becomes slowly like a vision problem. And then something like Isaac or TX or Habitat, or then that will be a very interesting benchmark. But I don't know what is there already anything in Habitat that has a benchmark or not?
Yeah, Habitat, I mean, for those who don't know, Habitat is sort of a simulation environment that is data-driven and has both sort of a first release that was focused on navigation, a second release that's focused on manipulation. And so they've had a series of benchmarks, but that go with competitions. And so usually, that it embraces also the metric parts and the success criteria. And they've had a series of those over the years, and this is planning to continue.
There's also like Gibson, isn't it? Like Stanford Gibson. They also
Gibson
have this.
is another side. Yeah.
Yeah, they also have
I
such
think
a.
both Habitat and Gibson are like in a house environment, right?
Which is
They're
important, right?
indoor environments, yeah.
That seems to be like
the
a.
community agreeing that indoor environment.
It looks like actually a lot of people, a lot of communities are working, or I mean, Toyota, TRI is working on kitchen, and Google is working with everyday robotic in the kitchen. So it looks like it's time for having a kitchen benchmark, placing objects in the dishwasher.
I mean, I think the advantage of indoor environments, again, like it's all about where the progress of research is going and setting the benchmark the right step away. The advantage of indoor environments right now is it's a lot easier to get a lot of good data, and a lot of these are photorealistic environments are built based on data. So, we get scans of indoor 3D environments that can feed the simulator. It's also easier to deploy robots and to have more robots try these tasks to do the sim to real. I think indoors, the variety of robots considered is maybe a little bit more reduced, and the variety of environments is also, even though it's still quite variable, more than if you start going outdoors. So
I think something I'd like to see the community focusing on regarding benchmarks is, now that we're bringing robots, for example, to kitchens, to really focus on what the safety features that we want, because soon, maybe you'll be in your kitchen and a robot will be doing the dishes, hopefully, or, doing some other tasks in your house.
Loading and unloading the dishwasher.
Yeah.
To know carefully treat a plate, but maybe a chair I can push around.
Yeah.
Okay, let's go to, we have 3 more questions, so let's take those. Go ahead.
I was wondering what you do to make sure your physics engine is like stable enough, simulates the environment good enough. What's the test that you do? How do you compare them to other physics engines?
Is that a question for Isaac,
Do you have
or
a specific?
are you talking?
If it's theirs or yours, I know there's a few differences. If you know.
I can talk about what we do in Isaac. So it's really, again, like one by one robot, like I would say, is that, for example, in the demo that you saw, which the work we did with Fraunhofer, which the robot has a very complex physics. It was just really tuning the parameters and checking it constantly with the real robot and see if it's like mimic it, right? So it's still, I think that the hard part is that we all have to confess is a little bit of like a manual labor there, right? So even let's say you have any mobile base, you play with the stiffness, all the physical parameters, because if you're interested in to see how accurate you're simulating it. And the good part of in NVIDIA is that we have a big physics team, right? And we constantly talk to them. Okay, for example, the caster, of which most of the mobile bases have like a small caster, and in real life those caster get stuck, or they get the friction goes over the time. So the accurately physically simulate that is not easy. So constantly talking to the physics team and making sure that we have all the things that we need. But it's not going to work out of the box, I have to say. Any robot you bring, you have to play and tune it to make sure is as close as possible to the real robot.
So that basically means that developing a physics engine is also a reinforcement learning process, right? You basically put out your first iteration of the physics engine, you get a customer trying it out, guess you the reward function that says I'm not happy because this doesn't work, and then you iterate on the physics engine. It's just like Orel actually.
I think Dieter once joined NVIDIA. One of his first goal was we need a physics engine that it has deep learning involved like in it, because it's really hard to like through like classic physics learn all of those physics. But as it learns and as you interact with it, as it learns the rules of physics, maybe that's the way to go.
So thank you very much for the presentation. So my question is related a little bit to what you were saying before about putting our robots out of the lab, like in outdoor environments. So because I think that probably that's the main value of simulation, that you can test like the same things in like really challenging environments. Because I would say that probably indoors is like fairly controlled, but when you want to go outside, you have all this variability. So I'm mainly concerned about simulating, for example, RGB data, because I think that in general we've been like quite successful simulating depth sensors, and we can see that they transfer really well. For example, with animal, like doing this perceptive locomotion that's based on depth data, you can do it and it works, but we want to get like more information about semantics. So I was wondering, on the one side of the simulation, and probably this is more focused on the people who work in the media, like what's your take on this? Because for example, all the domain randomization that we saw is still like under artificial, I would say. It's not like natural lighting or like shadows or like weather conditions. So I think we're still pretty far from getting like realistic conditions in that sense. And on the other, maybe it's like going more to the kind of the stuff that Lucado was doing, because basically we saw that they were dealing with these problems and they decided to do something completely different. That's basically running a rail in the real world in order to address all these issues. So it's more about like, what are your takes on this? Also, if you have something to say on this, I would be very interested.
Yeah, I don't think simulating the RGB data should be that difficult today. Maybe this is a bit of a bold statement, but I think we have just gotten so good at generative models of vision. And if you see some of the work that's been happening in terms of generating images recently, even from like prompted by text, like models like DALL-E and so on, but just the quality of the generation of the image that we have in those kinds of models is actually astonishing, to the point that it's becoming very difficult for humans to tell the difference. And so, and this may not have like made its way all the way to the simulators that we're using on the robotics side, but I feel like the progress in terms of our technology for generating RGB data is miles away from what it was 5 years ago. And so I think this is just a question. I don't know, maybe I'm too optimistic, but I feel this is a question of like people putting pieces together and coming together and like making it happen.
Yeah, there's two things, right? I mean, I really agree. I mean, NVIDIA has this RTX renderer, which is either a real-time ray tracer or a path tracer. They're really amazing quality, actually. They are almost like indistinguishable from real life, I think, if you give it a little bit of time to converge. Yeah. But yeah, what you said about having this generative model, then you can actually even generate more. Because if you have this RTX renderer, currently you basically feed it the data in, and then you get a photorealistic image. But if you combine it with neural networks, with machine learning, you can actually feed, yeah.
Let me add one thing that may not be feasible is to do it in real time.
That was my follow-up question.
and so I think that the quality is there, and when you're doing for simulation to then train a system, you can afford not to be real time.
I think it can be real time. You just need to throw a few more GPUs at the problem.
Exactly. But I don't think we're that far away from putting it real time. But I think if I just look at the technology today, what I'm seeing, I don't think is real time in terms of the framework that you need to train a robot online.
You can have it real time. And as you mentioned, it's like what you see many times. So for me, I would tell my story, because when I entered NVIDIA, NVIDIA is very specific in terms that artists and engineers live side by side, right? So, and as an engineer, many times we don't care about the look, right? Okay, it works fine. And I came in. It was like, I think a video or something. I said, oh, this is really nice. And all the artists were like so angry. The lighting is not right. The shading is, I didn't see any of that, right? So to me was, okay, this looks perfect. What are you guys talking about? So there's a lot of emphasis, like a big chunk of NVIDIA, they're artists, people that they care about every details of which is there. And honestly, I never can tell the difference there. So from the visual part, we are very, very good. Like many times, like we did a collaboration with Amazon, right? And probably if you look at search for some GTC videos, you will find it. But as we were working with these people, they were saying, is this real or is this real? Like it was, at some point, it was really hard to tell what's the difference.
Yeah, actually, I want to add one more thing to this. Because I've been working actually, the first thing at my NVIDIA was actually trying to see if my former teams could actually use Isaac Gym, and they are using perception on a real robot. And if you want to do perception on a real robot, usually you use already cropped images, because using like HD, like 4K images is too much for the neural network anyway. So they use like maybe low resolution, like 120 by 80 or maybe 240, you know, by. And what you can do is actually you can do batch rendering, tiled rendering of a huge amount of images. So, and they can all be photorealistic, but then you get still a lot of faster than real-time rendering, I think.
Yeah. So just, sorry to add one little thing, but one thing that is missing is that, and you have to do that in programmatically, is actually not to being that perfect. The cameras that we have in real life, they have noises, they have distortions, right? That is the part that is important. Like from the photorealistic part, we're really good. But what you can do right now is, and actually at NVIDIA, the drive sim, which is like for autonomous driving, has done a lot of work on it, and Isaac Sim is catching up. And that is once, like as I showed, when you have the OmniGraph, once the output of the rendering is coming out, now you can add like an OmniGraph node for more post-processing, to add distortion, to add noise to it, and like that will make it more realistic, not from the visual perspective, but from the like the device level and the physics part of it, because the cameras, the lidars, for example, the lidar is important. That the real lidar, if you have a shiny thing, if you have a black thing, is not going to do the job. It's going to go think, oh, this is free, it's going to hit the wall. Realistically simulating that lidar using RTX render, once you assign those reflectivity to all the materials of the objects, that's what is important. Not the visual part will already there, but even this, the drive sim has done a good job. They have at all these post-processing, the lidar and the radar that they're using is very close. Actually, there are some papers out there. They have done like on a calibration side compared with the real lidar outside. It's very close. On Isaac Sim, we're catching up. We're trying to go to device level simulation to make sure the lidars, the cameras all have all the distortions and the noise and all the imperfections that the real sensors have.
Let me jump in because we just have a few minutes left of Joelle. So you have done so much work on reproducibility in reinforcement learning. What is your message to the robotics community or the younger generation? Where do you, what should we do?
My message is a pretty high level one, right? But it's really to commit to research as a pursuit of knowledge. I find like so often we get caught up of research as, like as a competitive endeavor of like trying to be right, trying to be first, trying to be the best. And that's what leads us astray. And I think we really have to recommit to doing research as a pursuit of knowledge. And through that knowledge, we will achieve progress. But that embraces mistakes, that embraces negative results, that embraces all of the things that are maybe harder to see. But to me, that's the most important part. As long as we stay connected to that, then we'll do okay.
Thank you. Yeah, that's a powerful last message. Thank you. And we have 10 more minutes on this panel. So maybe we take one more question here, then one more from online.
Can I say something very quickly?
Yeah.
So I think like being able to reproduce the experiments, I think it's something that industry is really focusing on, because for example, our reinforcement learning, the RL scan has to run in the fleet of robots that we have, and the metrics for reproducibility, we measure in terms of how much kind of like different metrics, right? But how much output we have out of our machines, how much time they're actually doing their job and not having some sort of error. So it's something that I feel it's different now from my experience in industry than it is from academia. The focus on actually delivering a product that works, 24/7, 365 days a year, it's very important. So in terms of industry, that's something that we value a lot, being able to reproduce the results across, different warehouses, different robots around the world.
Great, yeah, thank you. Go ahead.
Hi. So I work on robotic grasping, and we are working with Pipelet to train policies. And we managed to do that using training on single object grasping and manipulation. And now we are willing to go to another use case, which is bin picking with a lot of objects into the bin. And I was wondering if you think Pipelet is still the right choice to do that, because we just barely started to work on that, and we noticed that it was really slowing down with the number of objects that we are using. So probably Isaac Sim would be faster to handle collisions and stuff. I don't know if you have some advice on that, and maybe on the limitations we could encounter working on graspings and manipulation with those kind of simulators.
I mean, scalability. I mean, Bullet is being used by everyday robotics. In Google, they do bin picking and grasping of a lot of objects, but you need to pay attention to your data and geometry. Like if you have a lot of vertices and a lot of complexity in the geometry, I don't know, I haven't seen your data, but that might be quite a bit. While, yeah, of course, I can easily say you can try out Isaac Gym. It's probably better optimized. That's all. Yeah, some simulators might be faster on the GPU, etc. So you just should try it out. Yeah, I don't think you need to be fixed on one simulator, right? Yeah.
Thank you.
Okay, we have one kind of a high-level question from the online audience, and the question is, how do you establish trust in people using kind of these machine learning systems who are not expert in that field, but are users of it?
Is that for anyone?
Yeah. I mean, you can also pass. This is a difficult
Yeah,
question, but
it's a bit philosophical.
It's also related to safety, right?
It's related to safety, maybe reliability,
yeah,
robustness.
So basically, one thing that we did at Google at least was adding a safety mechanism between the action and the robot. So you basically have the output of the neural network, and then we always have a safety mechanism to, not put too much torque or too much, hitting the joint limits, etc. That's one little thing I can mention, but otherwise I don't know.
I think for us, it's just deploying RL in production has been something of a breakthrough for us. So, some of the business part of Ocado is not, machine learning engineers. So the way to go about it is to just show the results, show how reliable the systems can be, just testing and showing that it's actually something worth doing.
Okay, I think we do one last round, one last question and get all of your answers. Is what do you think would be an amazing next thing the robotics community does in order to improve like the robustness, reliability of these solutions, or coming up even with solutions to problems that we haven't solved yet?
I think we have to do a lot of testing. Because sometimes in simulation things work fine, but then when we deploy into the real world, we have, as Lisa was saying, we have the cameras that have different errors and noise, and maybe we have delays in the signals that go around, and we have to think about safety if humans are going to be around, or safety of the robot or the environment. In our case, also safety, in some way of the objects that we're handling. So a lot of testing and learning how to improve this reliability and robustness.
I think it also goes back to this possible sim to real gap where you may maybe there's a more formal way to actually update your simulations as you also offering in the real world.
Yeah, I also feel that just trusting a black box neural network here might be a bit too much asking anyway. So having future more tools to visualize what's happening and to get to interpret what's actually happening on different layers might help. So like visualizing, yeah, because I think often looking at things makes very obvious that there's a problem, but you cannot look at numbers easily. So you need to, yeah, make it 3D, showing like with the nerves. If you train a nerve model, you can actually look what the nerve, what the output is. You can actually see whether it makes sense. And if you can break up your pipeline in certain ways, like model predictive control, you can actually see where the path goes, where the motor or where the robot thinks it should go. And you can have sliders as a user interface to actually control those model predictive control paths. Anyway, I think visualization to make the model better interpretable is might be one way.
Yeah, I agree. I think there's a lot of things. For me, the question was yesterday when I was watching the parade of the robots, right? One thing came to my mind, it was, when do we trust these robots to do their own thing? Like until when we walk with a joystick with them, because we don't trust them, right? Either we have autonomous on everything. So to get there is a long road. And we need, I think the good part of it, the optimistic side is a lot of things happening. There's a lot of like hardware side on the robot itself, on the GPU or CPU side of things. There's a lot of new sensors are coming. There's a lot of like AI is becoming more affordable and more streamlined. So the pieces are there. I'm guessing the simulation would be the part that help us to put these together and do a lot of designing and failing and doing it again and again and again until we are comfortable to have a parade of the robots that do it by themselves. Right?
Yes,
This is going to be a long road.
Yeah, still I want to add one more thing. You know, at home we have Amazon Alexa, and we are using it a lot, and we actually use language as a way to understand the model better. And it's also pretty obvious that Alexa doesn't understand your question. Like you say to play some music, and then you say play again, and then you hear the answer, I don't know what you mean. You know, like, so if you can add language as one of the interfaces to your robotic policies, etc., I think you go a good way. So you can just ask what's actually happening, and yeah.
So what came to my mind when I heard your answers is a robot is never really autonomous, right? There will always be an operator.
It's something, we're not trusting it, right? It sometimes does it, sometimes doesn't. And you don't want to hurt anybody, right? So we still want to be safe.
Still, there's an owner of the robot
Exactly.
that may be responsible in some form, or at least overseen in some high level capacity. And so we haven't seen any humans in any of these simulations. Is that something we should also think about?
Oh, we do have, like, there's a lot of humans, because again, like another app on top of Omniverse is about like simulating humans and different poses. So actually, it's even now possible to add a human in Isaac Sim. We don't have an example. We would have like in a release coming after in 2 months, but there's a lot of humans like that, like humans actually, like a big group at NVIDIA are working on simulating, and it comes two parts. Some part of it, you just have like a mocap to get like do the pose detection of the real humans. The other part is all through like deep learning and detection, because there's like, again, another product at NVIDIA, which is like Metropolis, and that is, you have cameras, you want to detect people, and the other part of the humans that you need, you cannot put actual cameras outside because many people don't want to be seen, right? I'll give you like an example that we're working with big industries is like many times, like let's say as automated factory, the humans are doing very hard work, right? They push something up, which is very heavy. And the simulation can help to what is the best way to do all that, but you cannot put actual camera because people don't want to be seen while they're working. So simulating that human, like doing that work in the simulator is going to be key to help out. And the goal is there to minimize all the hard work that the humans are doing and just give those to the robots, and we can do like easier works. But humans are in Omniverse already, different kinds of them. The freaky one and the non-freaky one.
Yeah, and also humans are also kind of very hard to interpret sometimes, right? Like if I want to know what you're up to, I look at your face, and then usually if you're lucky, you see on the face that you're smiling, you're probably up to good things, and if you're quite angry, it also shows
Or maybe
in the
I'm
face.
faking it. You never know.
True, but I think there's something called audio to face, right?
Right,
So you
right.
can actually turn it into a facial expression, and that's also one way to interpret models, right? So
Yeah, so the audio interface is another app on Omniverse, which basically turns your voice to like a person that is talking that. So you can, yeah. So there's a lot of tools there, like letting human, but you're absolutely right, because humans are a big part of it. Robots are going to live with us, so
Yeah.
they're going to interact with us.
I was even thinking as the human to be the operator and partially overseeing it or even providing input.
The
because
teleporting,
eventually,
yeah, yeah.
I think
that's only a short-term solution, right? Because
Yeah.
as you know, with the playing Go,
Mm.
you know, human has no way, it's just not strong enough to understand if the model is making the right decision, right? So we might still give up eventually.
I also want to go back to the problem of safety. I think including humans in all these simulations is going to be great to determine what the human is going to do and what is safe for the robot to do when it's maybe even collaborating with the robot doing certain tasks.
Great. So these were great final words. So we've heard we need to find the next challenging task as a benchmark that is doable, but really moves us in the right direction, that we need to pursue knowledge, that safety is important. And we've seen amazing work that in simulation that help us, I guess, accelerate research in robotics. So let's thank the panel again.